Okay, students, calculus, we're kind of at a little bit of the last track here, week 8, and this is the last thing that you're going to do. So, congratulations to those of you who are done with your mathematical career. No more math for you. Good for you. For me, that's a sad thing. Some of you, like me, you took 14 classes beyond calculus. Some of you will do that. Good for you. Sad thing to see your math career stop. I know some of you guys are excited about that. I'll try not to dwell on that. But thank you just about those of you who are continuing to take math. So especially those of you who are looking at calculus too, this is a great little trick here. And it's a nice way for us to kind of end the year and see something that you're going to have to know for a future class. And that's how do we find these antiderivatives? And the challenge is that if we have, say, the integral of 4 e to the x dx, it is just 4 e to the x plus c. If you have the integral of 6 cosine of x dx, it is just 6 sine of x plus c. But that works out really well. It doesn't work out this well in this situation because, as you notice, you've got an x out front here. And so you're really trying to undo the product rule. And so what we're going to do is I'm going to do kind of your last proof for you. And that is this. We know that the product rule, or if we take f times g, we take the derivative of that, you get f prime times g left alone plus g prime times f. Now, what I'm going to do is I'm simply just going to, substitute something in here. And that is I'm going to put large F. So if you put large F in here, so this is F and this is the derivative of that. Well, what's the derivative of large F? We say little f. And then we just have G plus G prime. And then, this F is here, is the same one here. So we're going to put large F there. So what I really want is I want an integral of FG. And if you notice, I'm just going to take the antiderivative of all this stuff. And antiderivative and derivative go away. So you're left with big F times little g is equal to the integral of FG plus the integral of big F times G prime. And if you move this over to the other side, you end up with big F times little g minus the integral of big F times G prime is equal to the integral of F times G. So notice how beautiful this is. This says if you want to take the antiderivative of two things that are multiplied together, easy. Just find the antiderivative of that guy times G left alone minus the antiderivative of big F times G prime. And I know that looks ridiculous, but it works out really, really, really well. And it's actually, the examples we're going to do are going to be pretty easy. This is something that we generally spend about 3 days on in class. We're just going to do the most basic problems. This has a kind of a term to it that we call integration by parts. And what integration by parts says is that if you want to take the antiderivative of FG, you do big F times little g minus the integral of big F times G prime. And what's really nice in this situation is you choose G to be something that when you take the derivative of, it kind of goes away. So look at this example here. The integral of 10x times a cosine of x. Now I'm going to choose 10x to be g, and I'm going to choose cosine of x to be f. Okay? So therefore we get the integral of 10x cosine of x is big F is going to be the antiderivative of cosine. What's the antiderivative of cosine? It's sine of x. G is just left alone. It's 10x. So notice here I have f times, or I have big F times little g right here, minus integral. Now watch what happens. You have big F, and if little f is cosine, then big F will be sine of x. And g prime is the derivative of 10x. And notice how the x goes away, I get 10. So g should be something that when you take the derivative of it, it comes out nice for this integral. So to finish off this problem, the antiderivative 10x cosine of x is just 10x sine of x minus, what's the antiderivative of 10 sine? Negative 10 cosine. Plus a constant. Two subtraction signs cancel out. 10x sine of x plus 10 cosine of x plus c. That's the antiderivative. Integration by parts. Look at this one. Negative 7x times e to the x. This is going to be g because it's going to disappear, and this is going to be f. F has to be something you know the antiderivative of. And we know the antiderivative of e to the x is just e to the x. So we get the integral of negative 7x e to the x is, dx. Sorry about that, guys. Forgot the dx on this guy. Big F, the antiderivative of e to the x is just e to the x. Times g is negative 7x. So that's how it starts out. Minus the antiderivative of big F, which is going to be e to the x, times g prime. What's the derivative of negative 7x? It's negative 7. So it'll be a plus 7 there then. So you have negative 7x e to the x plus, what's the antiderivative of 7e to the x? It is 7e to the x plus a constant. You found the antiderivative. Simple formula, integration by parts. I know that you maybe didn't completely understand the proof and how we got it, but if you go back and watch it, you probably understand better if you saw a second or third time. And going through that process really isn't that bad at all. We'll try one more, give you a little bit further run for your money. We have the antiderivative of negative x sine of 3x dx. Again, not a super complicated problem, just a little bit of a step up. I'm going to again call this g because when you take the derivative of it, it goes away. I'm going to call this f. Okay, I'm going to call that f. All right. This is a little bit more involved. So instead of rewriting, I'm just going to say equals. We need big F times little g. Well, little g is negative x. Sometimes people like to start off like that. But now I need big F. I need the antiderivative of this. And while you know the antiderivative of sine is negative cosine, what's the antiderivative sine of 3x? Well, you would have to use substitution. So I'm going to do some scratch work over here. The antiderivative of sine of 3x dx, u is equal to 3x, du is equal to 3 dx. I don't have a 3 dx, so I have a 1/3 du is equal to dx. So I have a 1/3 integral sine of u du. So you can see the antiderivative now of sine of u is negative cosine of u, and u is 3x plus c. So you can see sometimes you end up having to use substitution when we don't end up with simple examples. All right, so the antiderivative, so we just did big F right there, okay? So little g, we said is negative x, and then big F is negative 1/3 cosine of 3x times negative 1/3 cosine of 3x. I'm going to rewrite this to just be 1/3 x cosine of 3x, okay? Minus the antiderivative of, what happens when you take the derivative of g? You get negative 1. So that's going to, the derivative of g is going to get negative 1, so that's going to go away. And then you have big F. And we said that big F is 1/3 cosine of 3x. So that negative sign is going to come back in, 1/3 cosine of 3x. So in order to answer this, I just have to do this piece right here. I'm going to need to use substitution again. I have 1 over 3 cosine of 3x dx. That means u is equal to 3x. So du is equal to 3 dx. I don't have a 3, I have a 1/3. So how am I going to come up with a 1/3? Well, if you have 3, we're going to have to divide by 9. 1/9 du is equal to 1/3 dx. So it becomes 1 over 9 integral of cosine of u du. The antiderivative of cosine is just sine. 1/9 sine of 3x plus c. So we just answered that. 1/3 x cosine of 3x minus 1/9 sine of 3x plus a constant. And that's our result. Again, integration by parts. We're at 11 minutes. Because we have a couple minutes, I'm just going to do one more problem. This is just for pure fun. And that's just to do just a great problem. Natural log of x dx. You know that the derivative of natural log is 1 over x, but you don't know the antiderivative. And a method of finding tricky antiderivatives is to be able to use sometimes integration by parts. I'm going to call this not f, but I'm going to call it g. And the reason why is because I know the derivative of it. But I don't have another function. What am I going to call f? I'm going to put a 1. 1 times the natural log of x. We're going to call that f. And so therefore you get, what is big F? If little f is 1, then big F is x times g natural log of x minus the integral of, what is big F? Big F is again x times g prime. What is the derivative of natural log? It is 1 over x. They have a dx. So x natural log of x minus the integral of, what is x times 1 over x? It's 1. What's the antiderivative of 1? It's x. Turns out that, my friends, is the antiderivative of natural log of x dx. It's a beautiful thing. Integration by parts is a super powerful way to be able to find tricky antiderivatives. And I know that for some of you are like, okay, I've been done with calculus for a while, but a lot of others of you are handing on this idea of you're still wondering, wow, what other antiderivatives don't we know? And this is just the amazing thing. You got used to taking derivatives. Finding derivatives is easy now. We can find the derivative of anything. But finding antiderivatives, super challenging in some situations. This is just another technique. There are antiderivatives out there that we just really struggle to figure out at all. So, it's been great having you guys. Love you, class of 2020. Have a great, great summer. I hope to see you on graduation. I'm holding out hope that we're going to be together soon before you know it. And we'll see you soon. Be a great Tiger. Enjoy your great week. Be a leader.